In this video, I'm going to show you a simulation of refraction in a glass block. Okay, so as you can see, I've got the glass block here, and I've got a ray box that I can move around this page to give me light coming in at different angles. You'll notice the simulation set up so the light always hits at the same point on the block. I'm getting a little bit of reflection off the block. That's perfectly normal because the glass is quite shiny, so you would actually get that. And if you look at the way that works, you'll see that this line here is also simulating anything you've done on reflection. Okay. Okay, so now what I'm going to do is I'm going to set up the simulation so that I can actually take measurements. Okay, so I turn on the protractor, and as you can see, the protractor is looking at what's going on where the light hits the block. It isn't looking at what happens when the light comes out of the block over on the left-hand side here. So the first number I'm going to use is I'm going to use between 0 and I'm going to go up to, I could go up to 90, but we'll see how far I can go with the simulation. The first number I'm going to do is actually 0. So I'm going to move the ray box round, and then I'm going to actually set it to 0. I'm then going to go up in steps of 10. So here we go, here's 0. So as you can see, I've now got the light going through at 0 and it comes out at 0. So my first result. Okay, so what I'm now going to do is I'm now going to do my next result. So the first one is 0, 0. The second one is going to be 10. And as you can see over on the left now, left side of the protractor, I've got a value that's somewhere in between 6 and 7. Okay, so from what I can see, it seems to be closer to the middle of the two numbers than it is to either of the two numbers themselves. So in between 6 and 7 is 6.5. So I'm going to say that this result is 6.5, with my uncertainty being 0.5 for every measurement all the way around the protractor. Okay, so let's put that result in. 10, 6.5. Okay, so what I'm now going to do is the same thing again for 20. Let's move it around to 20. Okay, there we go. So that is now going to be 10, 11, 12, 13. It's closer to the 13 than it is to the halfway point, so I'm going to call that 13 exactly. And then I'm going to work my way around doing exactly the same for each point on this system. So I can do 30, 40, 50, 60, 70. Okay, so as you can now see, I've done up to 70, which is my new maximum after I found the simulation won't go any higher. So what I've now got is a nice pattern where you can see that as the angle of incidence increases, the angle of refraction increases. What I need to do is check what kind of relationship this is. So what I'm going to start off with doing is I'm going to put a trend line on. I'm going to assume that the trend line is linear, which means a straight line. So let's have a look at what that means. Okay, so I'm not happy with this trend line. If I make this window a bit bigger and we have a look at the graph in a little bit bigger size, you'll see that that trend line isn't a very good approximation to what's going on. There's a shape that looks like a curve that looks much better than that best fit line. So I would say that this best fit line isn't the correct pattern. So the angle of incidence and the angle of refraction are not directly proportional. Okay, so all we can really say is that there's a relationship between the angle of incidence and the angle of refraction, where as the angle of incidence increases, the angle of refraction increases also.